Sterochemistry of Rabeprazole under the supervision of as-Prof Mukhtar Al-Ghurafi. Stereochemistry. Stereochemistry is a study of how molecules are affected by the way their atoms are arranged in space. It's also known as 3D chemistry, as the word stereo means three-dimensional. Using stereochemistry, chemists can work out the relationship between different molecules that are made up from the same atoms. They can also study the effect of physical or biological properties that the relationship give molecule. When these relationships influenced of the reactivity of the molecules, it's called dynamic stereochemistry. In chemistry, some molecules have more than one isomer. This means that molecule can have different forms, even though all the forms made up of the same atoms. There are two kinds of isomers. Conditional isomers have the same atoms, but they are joined differently. Stereoisomers have the same atoms. They are joined the same way, but the atoms are arranged differently in space. An important part of stereochemistry is the study of chiral molecules. These molecules look almost identical except that one molecule is the mirror image of the other. In the most chemical bonds, the atoms of molecule free to move around without breaking the bonds. When the molecule has double bond or ring structure, the molecule can be stored into different isomers. These are molecules with the same chemical structure but different forms. The study of stereochemical problems covers the entire range of organic and inorganic, biological, physical, and supermolecular chemistries. Types of stereoisomer. A tropoisomerism is the property of any molecule or an object of being non-superimposable or its mirror image. Cis-trans isomerism. Cis-trans isomerism shares the same atoms which are joined to one another in the same way but have different configurations. Conformational isomerism is the type of stereoisomerism in which isomers can only be converted by formally signal bond rotation. Diastereomers are optically active isomers that are not enantiomers. An enantiomer is one of a pair optical isomers that structure of which are not superimposable on their mirror image. Isomers. Structural isomers, stereoisomers, diastereomers, enantiomers, cis-trans isomers. Conforms. The different type of isomers. Enantiomers. When two isomers are mirror image of each other, the type of isomers is called enantiomerism, and these isomers are referred to enantiomers. Enantiomers are the stable and insoluble compound that divide in their spatial arrangement in 3D space. They generally excite as discrete pairs. The properties of enantiomers are identical. However, their interactions with a plane or polarized light can. Diastereomers. When two isomers do not behave as a mirror image of each other, they are called diastereomers. A molecule with n number or asymmetric carbon atoms can have up to 2n diastereomers. When two diastereomers differ at only one stereocenter, they are referred to as epimers. These isomers vary in physical properties and chemical reactivity. An illustration of enantiomers that are mirror image of each other is proved below. Chirality. Chirality is derived from a Greek word chir that stands for hand. An object is said that to be chiral if the object, its mirror image, are non-superimposable, just like our right hand, left hand. Now you must be wondering that we mean by non-superimposable when the mirror image of the object is placed over the original object and they do not overlap, as shown in their figure below. Then the object and its image are said to be non-superimposable. Chiral object, left hand and right hand, cannot be superimposable. A chiral object, left hand, right hand, can be superimposable. Randomly alternated light, polarizing flatter, planned polarized light. As stated, chiral molecules are optically active, when implies that when a beam or planned polarized light passes through the chiral molecule, it is interacted with the molecules in such way that the angle of the planned of oscillational rotate. Planned polarized light, chiral simple rotated light. Examples. How to identify chiral carbon centers. The rule of thumb is a chiral carbon centers are carbon atoms that are attached to 4 different substances that are placed at corners of tetrahedron. Chiral carbon atoms are also referred to as stereogenic carbon or asymmetrical carbon atoms. Chiral identification. Chiral centers since carbon is attached to 4 different groups. Compound 1 has a chiral carbon center because it's attached to 4 different groups. Compound 2 is a mirror image of compound 1. As per of definition of chirality, compounds 1 and 2 should be non-superimposable. How do we confirm this? Let's rotate compound 1 round 1 axis of rotation and see if any of the products of rotation leads to compound 2. If not, then compound 1 is a chiral. So let's go ahead and sequentially rotate compound 1 about the CX axis and clockwise direction. The various products of rotation and shown below. So as you can see, none of these above structures is the same as the mirror image, compound 2. Thus we can convey that compound 1 is a chiral. Before we moved on, let's try identify if the carbon atoms in the following 3 compounds is a chiral center or not. This carbon atom is chiral because it's attached to 4 different groups. This carbon atom is not chiral because it's not attached to 4 different groups. This carbon atom is chiral because it's attached to 4 different groups. Enantiomers, positive and negative, R and S isomers. A chiral compound and its mirror image are referred to as enantiomers, so we can define enantiomers as being 2 stereoisomers that contains asymmetric carbon atoms and are related to each other as a non-superimposable mirror image. Enantiomers differ only in their optical activity, in the definition, in direction. in which they rotate polarized light. If an enantiomer rotates polarized light to the right or in a clockwise on the clockwise direction, it's said to be the negative, the positive or dextrosity. Isomers, on the other hand, if the plane polarized light is rotated to the left or counterclockwise direction, if the stereoisomer is called as the negative or laboratory isomer. Enantiomers have the same physical properties except for the direction in which they rotate plane polarized light. Since these isomers exhibit different optical activity, they are sometimes also referred to as optical isomer. Racemic mixture. In chemistry, a racemic mixture or racemate is one that equal amounts of left and right-handed enantiomers of chiral molecule. This first known racemic mixture was racemic acid, which Lewis found to be a mixture of the two enantiomers, isomers of tartaric acid. A symbol with only a single enantiomer is an enantiomerically pure or enantiomer pure compound. Racemic mixture versus meso compound. A racemic mixture meso compound. A racemic mixture is a mixture of organic compounds known as enantiomers. A meso compound is the molecule having more than one identical stereocenter, is an identical or superimposable mirror image. Contains non-identical isomers. Contains identical mirror images. Contains chiral compounds. Contains as a chiral compounds. Identification of rabeprazole. Name: rabeprazole. Ascension number BDBO1129. Description: rabeprazole is a nuclear drug in the class of proton pump inhibitors. It is a prodrug in the acid environment of critical cells. Turns into active sulfonamide from rabeprazole inhibits the hydrogen positive and potassium positive ATPase of quieting gastric cells and thus dependent of special and stimulated gastric acid secretion. Rabeprazole side effects. Rabeprazole oral tablet doesn't cause bruisiness, however it can cause other side effects. More common side effects. The more common side effects of rabeprazole can include headache, pain of the abdomen, sore throat, gas, infection, constipation, diarrhea. Uses. Rabeprazole is used to treat severe gastrointestinal conditions. This includes heartburn and other symptoms related to gastroesophageal reflux disease. Occurs when acid in your stomach backs up into your esophagus, the tube that connects mouth to the stomach. This can use a burning feeling in the chest or throat, a sore taste in the mouth, or burping. Dundilla unclears. Sores in the first part of the small intestine. Includes ulcer caused by the bacterium H. pylori. Contains that cause the stomach to make too much acid. This includes a rare conditions called Zollinger elation syndrome. Mechanism of action. Identifications of rabeprazole. Stereochemistry. Racemic. Molecular formula C18H21N3O3S. Molecular weight 359.443. Optical activity positive and negative. Defined stereo center 0 to 1. EZ centers 0, charge 0. Type small molecule. Groups approved. Investigational. Synonyms: clofazone, rabeprazole. EUPAC name, generic name, rabeprazole. Structure of rabeprazole. Stero. (3D structure of rabeprazole). Done by